Well, hi everybody, I'm John Keller. I am a Principal Edge Specialist with AWS. As Seabury said, I've got two co-presenters today. I'm joined by the Global Business Development Lead for Edge, Tarshia Weldon, and then also Nishit Sawhney. Nish is the Global Product Manager for CloudFront. So we're going to talk about Edge at scale. So let's jump right in. Suppose that you ran a little website called hurricanes.gov, which our friends at NOAA do, and that about 36 hours before this took place, you said, boy, this is going to be a doozy. You know, Harvey had just finished making landfall, and now we've got Irma, Jose, and Katia. The first time that you ever had three fully formed hurricanes in the Atlantic and the Gulf, all headed to make landfall. And you said, you know what? All the big news agencies link to our site. Drudge, ABC, NBC, CNN, MSNBC, they all send their folks there to look at hurricane tracks, models, satellite photos like this one. What are we going to do? We're in our own data center. We're running our own clustered, web servers. How do we scale this out? And so happily, they used AWS Edge. They had worked with us over the summer when the eclipse was coming. Of course, we knew about that. Some of the Mayans, I suppose, knew about it for thousands of years, but so did NOAA. And so they had done some POCs with Edge. And within 36 hours of figuring out this was going to happen, we had tested and deployed and put Edge services in place so that when this happened, on their peak day, they had millions of unique visitors and over 1 billion hits against their website. They didn't have to scale their back end at all. The Edge on AWS did it for them. Second example, I'm giving you a bit of an eye test, I know, but this is the National Archives website. Their backend's in AWS, but sort of a similar problem. Nobody wants to scale out for a large event. In this case, it's the JFK files, the most anticipated document release in recent memory. And the tweeter-in-chief on October 21st said, files will be released. October 26th was the drop date, and they had worked with us previously. They kind of knew this was coming. They'd scheduled it out. And so happily, again, millions of end users, hundreds of thousands of downloads of these large files, a big zip file of all these documents, delivered at the edge, scaled out, no issues, without busting the bank on the back end either. So those are just two examples. I wanted to give a quick shout out. What would a PowerPoint be without a logo slide? Is anybody's logo up here? Anybody? Raise your hand. No? Darn, I wanted to say, we thank all these clients anyway for trusting their mission with AWS. Now, you'll notice something that I noticed as I was putting this together. We like to do kind of specific. I don't just recycle. I wanted to be very specific for public sector. And the ed tech clients really sort of dominated this. And it got me thinking, why is that? And I was kind of trying to make logos bigger. And I said, no, actually, this tells a big part of the story. And so the benefits that we're going to talk about today, there's really three that I want to discuss with you. And the ed tech clients are so honed in on this because a lot of them are sort of born in the cloud. They're nimble startups. So they've got to be very cost conscious. So we're going to talk about cost optimization. I'll come back to that in a moment. We already talked about scale. So ed tech clients are very video-centric. A lot of them are serving K-12 and then college audiences. They're restreaming lectures or mini talks. And video is kind of a high bar for performance on the internet. It's very heavy. It can be difficult to do. So if you can do video, you know you're doing a good job. So they're really interested in performance, which is one of the big benefits that we'll talk about. Interestingly enough, other than maybe state-sponsored black hat hackers, ed techs have some of the hardest security requirements because nothing is more motivated to take down your site than a bored 17-year-old who wants to change his grade or hack the teacher's blog. People are laughing. It's true. They actually have a ton of security requirements, both at kind of layer 7 specific targeted attacks as well as DDoS attacks. So as I was kind of thinking about this, putting this together, I said, you know what, they're the perfect sort of poster child for what the big benefits are. And so again, it's performance, security, and cost optimization. Now I've said cost twice. Who here, by show of hands, hates their data transfer out line item on their AWS bill? Come on, nobody hates that? Yeah, they're doing the logic. Yeah, I don't like that part of the bill. I'm going to show you what I think is the biggest hack in AWS for cost optimization. You got to stick around to the end. This is my ethical bribe to you to get you to stay and not try and get into the party early. So, but a big promise like that needs a big challenge too. So I'm going to challenge you. I want to show you why I think that every bit of your HTTP and HTTPS traffic should be delivered through the edge, whether it's coming off of your data center or especially out of an AWS data center. And it's going to tie into that cost optimization. So that's my challenge to you, but also my ethical bribe to get you to stay until the very end. So I mentioned the edge. Let's talk about, first let's look at the kind of the physical map of the edge, because we do a good job of talking about cloud in very esoteric and sort of fluffy terms, but let's drill down because this is important for understanding the context of especially performance and scale and security, those benefits. So what I've shown here, you've got 119 edge locations, and they're spread all around the globe. Our latest one is in South Africa, Johannesburg. It's covered up by the graphic there. We're going to have to redo that graphic. And then in white there, you've got the regions. And connecting them, I know it's a bit of an eye test, is our high-speed fiber backbone. So there's really three components here. At the edge, not really pictured, but in those edge locations, that's where we buy transit and bring peering in from the local providers and the big national providers. So when you think about the British Telecoms, the Orange, the Telefonicas, the Verizons, the AT&Ts, the list goes on and on of all these partners, they're all connected locally at these edge locations. So all the eyeball networks where your audience, your constituents, your viewers are coming from are connected very closely. And then dragging that data back, if need be, is the fiber backbone. So keep that in mind as we kind of go through the presentation and talk about these benefits. So what's at the edge? So this is a drill down a little bit. It's a left to right here. In the main box in the middle, I'm showing you the drill down of the various services that are delivered at the edge. So first, in the top left there, you've got Route 53. This is global intelligent load balancing, DNS based. Below that, you've got AWS Shield. So Shield we'll really spend some time talking about. This is real-time, inline, always-on DDoS protection. Next, you have AWS WAF, Web Application Firewall. This is layer 7 detection and blocking for application-level threats for HTTP, HTTPS. Then you've got CloudFront, which is dynamic and static whole site delivery. It's a CDN technology. And then Lambda at the edge in there as well. We'll really drill into that a little bit too. And then you can notice here a couple of things to notice. One, I've got an origin here. This is kind of the quote-unquote real web server, right? The authentic web server. That can either be in your data center or it can be in an AWS region. And we connect to it either via the open internet or the AWS backbone or direct connect. The direct connect would actually go into a customer data center. So multiple ways and components, just a very high-level topology of the various services and kind of the left to right of viewers to website, how it all fits together. So I've mentioned CloudFront. That's kind of the cornerstone, one of the cornerstone services there for the edge. But it's a global content delivery network, CDN. As I mentioned, it does the whole site delivery, or it can just do API delivery or just image delivery. You can carve off various pieces of the site, whether it's static or dynamic content. And as I mentioned, it can do either an AWS origin or it can do a custom origin. So if you've got your own data center, we can route traffic there. You get a full set of security controls that we're going to dive into. This is where WAF is applied, and as I mentioned, Shield is sitting in front of it. And then there's no sort of secret portals or secondary portals. If you've dealt with other CDNs, sometimes you have to get professional services involved. You have to open tickets. You don't have access to everything. We've got a real DevOps focus on CloudFront. So you can do everything. There's no sort of nothing held back from you being able to do it. Everything is controlled by the API as well, as you would expect from AWS. And then finally, cost effective. I'll get more to that right at the very end as I'm holding you here. So let's talk about how this works, because I get a lot of questions about, okay, CloudFront sounds cool, it's CDN technology. How do I push my stuff? How do I publish it to CloudFront? And so really on this slide, what we're looking at, again, the left to right here, for your end users, there's really only two steps. Obviously, if you've already got a website up and running, there's a little bit of DNS coordination to do. But what you do, in the top left there, you're going to create a CloudFront distribution within the console or the API. And you'll get assigned a CloudFront distribution name, D12345. It's longer than that. And so you've got this distribution name. And then within that distribution, you'll tell it, hey, it's www.mywebsite.com is what you're going to answer to. So you give it a CNAME. And then you can test that distribution, obviously before you do anything. You also, as part of that, you tell it what its origin server is. So CloudFront, you don't actually publish your content to CloudFront. You just tell it where to go fetch the content from. That's the origin. And so you tell it what your origin server name is. And that origin, again, that can be an Apache server in your own data center. That can be an EC2 instance running Nginx. That can be an S3 bucket. As long as it is a web server and CloudFront can talk to it, you can use it as an origin server. And then as you can kind of put the pieces together here, so you create the distribution, and then there's a little bit of DNS coordination. There's lots of how-to and getting started guides on this on AWS Docs that you can look into to kind of coordinate it. But it's really that straightforward. So when you, the end user there, number one in the top left, types in their browser www.example.com, and the browser says OK, and it resolves, and DNS resolves to CloudFront location that's closest to him. So remember in our slide with the backbone, this user might be in, I don't know, Waco, Texas. And so they go to the Dallas POP that's topologically very close, right? Boom, there's that CloudFront location. That POP says, oh, this is a new request. I haven't seen this content before. Looks in its configuration. Where do I get it? Oh, I go to the back end here, whatever that is. And again, that can come over the AWS backbone if it's within AWS, or over the open internet if it's going to your data center. Fetches the content and sends it to that end user. No problem. Now, here's the benefit. The next person that comes in, down there in Houston, they need to do the get. CloudFront says, oh yeah, I got that. Boom, there we go. So it's given to the end user very quickly. And you notice I didn't talk to the origin. So if you think back to our example, our NOAA example that I was giving, the National Archives example I'm getting, where you've got millions and millions of end users coming in, they offload all that at the edge. CloudFront is handling all that traffic. All those billions of requests and millions of users are handled right there at the edge. And so my back end doesn't have to scale up. Huge benefit. And you say, OK, well, this is great and all, but I've got a dynamic site. Only 10% of my content is, JavaScripts and CSS files and maybe a few icons, but 90% of it's dynamically generated. What do you do there? How do you help me out there? Because I don't see much benefit in using this. Maybe it's too complex. Aha. So there's lots of techniques that we use actually to accelerate dynamic content. So the first there, we'll actually collapse multiple requests for the same object. So a lot of times, like, if you say, hey, we're going to drop this document precisely at noon, it looks kind of dynamic, right, because it's not in cache. Well, guess what? If you get 50 or 100 or 1,000 simultaneous requests for the same object, we'll collapse those into one request going back to the origin, and then the edge will handle all the rest. So again, a great way to content offload. Or if you're expiring your objects and you've got a large amount of traffic, again, you might have 50 or 100 simultaneous requests for something popular. We'll collapse all those down and ask for it once from the origin and go back. Second thing, we'll optimize the network path. So those of you familiar with TCP, the incorrectly named TCP fast start is a mess. We optimize for that. TCP windowing, all these sort of tuning things that we can do to keep that going fast. We also do keep alive connections to reduce the round trip time on TCP. And again, it's coming over the AWS backbone. So it's not over the open internet to get from point A to point B. We're going to go over the backbone to hit especially your AWS resources. There's some additional SSL optimizations and TLS optimizations that we do. So I'm going to dig into one for just a second to drive home the point. This is an example of the TCP three-way handshake in a request. So the first user comes in, the three-way handshake, if he's 100 milliseconds away from your origin server topologically, it's 400 milliseconds before I actually do my first GET request. That's before a byte goes back. It's 400 milliseconds. Second user, same issue, exactly the same, right? So what happens when I put CloudFront as an edge proxy? Well, the first user, it's 400 milliseconds still. We can't do anything about the speed of light, not yet. So 400, the way the math works out, trust me on that. But the second user only has to do the handshake to the edge. If the second user is only 20 milliseconds from that edge, remember in our example we were talking about the Dallas POP is being very close here and the backend's in US East or wherever, that TCP connection on the backend is kept alive. And so I've cut my time by 40% with that one optimization. I've cut it from 400 milliseconds down to 240 milliseconds. So this is a tremendous benefit, even for dynamic applications. And that's only one example. Remember, I had four others on that slide. So finally, CloudFront has incorporated Lambda at the edge. So when you get an edge request, this is a version of Lambda. It is triggered on one of 4 triggers. When a request comes in from an end user, when I have a miss and I have to go back to the origin on a cache miss and talk to your origin for something, when I get a response from the origin, and when I send data back out to the end viewer. Those are your 4 points. And common use cases for this, it's all the benefits of Lambda in terms of no servers, it scales and so on at all the locations. And you can do things as simple as redirects, to a little more complex, like token authentication, to complete image rewriting, and now we can talk to third-party data sources here at the edge. So if you wanted to stick something in the Dynamo, for example, right at the edge, you could do that. You don't have to write some, strange process coming off of your origin server to do that. You can offload your origin architecture and right there at the edge, push or pull a record. And you're globally distributed right away. As I said, this is executing at the edge, so you have all the scalability that you've come to expect. So there you go. Bring your own code to the edge. So, okay, so hopefully I've done a good job so far in our limited time talking about how CloudFront works, even at a high level, to give you the scale that you're looking for, that performance promise that I made in terms of not only reducing the time that it takes to get images, to get your data back, but also the ability to offload your origin so that you're not overwhelming it in case you have an unexpected or an expected increase in usage. But I also mentioned security. So again, job zero at Amazon, let's talk about that. Within CloudFront itself, we'll drill in for a few minutes and talk about the security features that are built in. There's a number that are built right into CloudFront that you don't even have to think about or worry about. These are functions that you can enable in the console or via the API just natively. Second, we've got AWS Shield Advanced. I mentioned all my EdTech clients at the very start and how a number of them are using this because they're getting DDoSed, and not just necessarily by script kiddies, but by people who actually have taken time to try and do something nefarious. Most of my clients don't need this. There's Shield Standard built right into CloudFront, so you get DDoS protection natively with no additional cost. Some people need more, and we'll talk about that. I mentioned the WAF several times. So this is the layer 7 inspection, looking into the actual HTTP request, looking at the URI, looking at all the headers, looking into the body, and figuring out, is somebody trying to do something nefarious here? We'll talk about that. And then finally, AWS Firewall Manager. So Firewall Manager, newer service, it actually coordinates and is a policy management system to make sure that your WAF rule sets that you want are deployed across your distributions and so on, as you would expect. So it's really doing that policy management to make sure that within your account, you don't have people who've stood something up, they think they're protected, but they're actually not. So Firewall Manager. So I told you the CloudFront had a number of things baked into it. I mean, the first and foremost is just HTTPS. That's the direction that the internet is going. We're huge proponents of that. CloudFront includes that. You terminate your TLS at the edge. You can then re-encrypt, go all the way encrypted end-to-end back to your origin. There's no additional cost to do that, and it's the same network. So again, if you're similar with some legacy CDNs, they have sort of subsets or they charge a super premium. This is all standard out-of-the-box stuff with CloudFront. We give you all the additional things you'd want in terms of the advanced ciphers, certificate stapling, PFS, and we can restrict access to certain geographies. I know that's a big thing for a number of our clients in the federal space, as you say, you know what, I just want to restrict this to just the continental United States plus outlying territories. You can do that, again, out of the box. We launched Certificate Manager, so we'll actually give you certificates for free that you provision and deploy right on CloudFront. So www.yourwebsite.com is now locked down. You don't have to go to a third-party provider and buy a certificate. We'll give it to you for free. We'll host it for free. There's no charge for the hosting on CloudFront itself, and there's no surcharge, as I mentioned, for delivering that as HTTPS traffic. So we're big believers in security, and we definitely have made investments there so that you don't have to and bring this value to you. At the bottom here, you can see we've got all the security and compliance kind of acronyms to back that up. FedRAMP is in progress. We actually have our ATO right now. So those of you that are in the federal space for whom that's important, we've got that. You can request the package. Come see me after, and I'll get you set up. And then the JAB is ongoing right now. The FedRAMP team has got that, and as soon as the FedRAMP actual government board has approved it, you'll be the first to know along with me. So we'll have that rolled out. We expect second half of 2018. So I mentioned Shield a couple of times. And again, this is the same left to right here. So on the left, we've got our users. On the right this time, I'm not showing your back end. I'm showing our DDoS response team. It's a big part of Shield Advanced because what happens is DDoS attacks do happen. And remember, this is an edge node. So a big benefit here is you've got the very distributed attack surface. Remember, there's 119 of these and growing all around the globe. And so we can actually block the attacks close to the source. You don't get this sort of avalanche, funnel effect of all this DDoS traffic coming in and causing problems. Right there at the edge, we can block that traffic. So that's sort of thing one. Shield is what's doing that. So we've been working on this for years and years. We actually released it as a product a year and a half ago, but we've been working on the technology for multiple years. We just hadn't made it multi-tenant. So it will actually detect and block DDoS attacks, 99% of DDoS attacks in under 1 second. Automatic mitigation. This is especially true of layer 3 and layer 4 attacks. So, those are, they're kind of very straightforward signatures, right? Like, oh, look at that. I just got 5 SYN requests from the same IP address that didn't wait for a SYN ACK, and I got them all in 30 milliseconds. That's a DDoS attack. Let me go ahead and drop that, traffic. That's no good. So that's sort of line 1 in the defenses. Behind that, we've got the DDoS response team. They're monitoring internal tool sets, and so they know we've got a baseline of traffic here. Oh, we just spiked. There's something going on. We've got an anomaly. We can take action. So the DDoS response team, again, this is, you send up the back signal. You're under attack. They have a 15-minute response time SLA to be live person support on a bridge with you, working to mitigate this attack. So they'll come in, and what they can do is they can actually work with you, look at the attack signatures, and create custom mitigations that they'll especially push into the WAF if you've given permission. I mean, your security policy has to allow this, and you would set it up. You delegate permission to them at setup time. Or they can just recommend. They say, here's what we're seeing. You can build this yourself. But they'll push those signatures into the WAF. That's typically where they're finding that things are getting through. Layer 3 and Layer 4, again, are very easy to understand that this is an attack. Layer 7 gets a little bit trickier. And so they'll push those custom mitigations or give you the recommendation of what you want to push, protect you. So again, the differences between Shield Standard and Shield Advanced, Shield Standard does a great job. Most of my customers do not need Shield Advanced. Shield Standard is fine. They'll come under an occasional small attack that's kind of a dumb attack, like a Layer 3, Layer 4 attack. No problem. Shield Standard will block that. It's built into CloudFront. Again, no additional cost to you. But Shield Advanced does have a lot of extra stuff that's nice, especially for clients who are getting attacked. So I mentioned across the top here, I mentioned the DDoS response team already. You get this expertise on call, live people to really help you out if you get something more complex. The second row here, visibility and compliance. So CloudWatch metrics, remember that I showed that little anomaly spiking up there? Guess what? With CloudWatch, we know when we're under an attack, and so we can create alarms and alerts. We can create an SNS topic. I can ping a Slack channel, an on-call pager, an alias email, so that we know somebody gets notified. And then from there, they can look at the attack diagnostics itself, because even if you're under attack, you may not have to do anything. It's nice to know you're getting attacked, because sometimes that's a precursor to something worse or something bigger, so you want to know. And so you go into the threat dashboard here, and you look at your particular attack, and you can understand how many requests per second, how many megabits or gigabits per second am I getting attacked with? Do I need to take any action? You get a global threat environment dashboard, so that when you're not under attack, or if you are, you can kind of see what's going on in the world, what are the typical attack vectors and the sizes, what's happening out there. And then finally at the bottom here, you get a number of economic benefits. So you have WAF at no additional cost for your protected resources. So that's a big benefit. You don't have to pay for it. You get Firewall Manager at no additional cost too. So we say, hey, here you go. And then finally, such a small thing it seems, but cost protection for scaling. This is an insurance policy against a financial attack on you by running up your resources. So let's say that they're attacking you, and it's a pretty tricky attack, and so you're handling it, but you've got an auto-scaling group, and suddenly you go from your normal 4 or 5 EC2 instances to 15 or 20, and it runs for a week, and I've got all this ALB processing, and I've got data transfer out, and we just can't quite put a signature in place that blocks it, and so the site's still functioning, but at the end of the month I run up a $10,000 or $15,000 bill that I wasn't expecting. We looked at that and we said, in that case, the attack has worked, because it's done financial damage to you, even if it hasn't done reputation damage or taken the site down. And so this is an insurance policy. You won't pay that. And that's included with Shield Advance as well. Now, I've mentioned WAF a couple of times, the Web Application Firewall. Some big differences here. Again, this is at layer 7. We're looking into the HTTPS requests. Traditional WAFs kind of sit, on a pair of high availability boxes in a cluster right in front of the inbound traffic going into your load balancer or out of your load balancer before your web server. We're sitting out at the edge, so that's a big topological difference and a big benefit. We're distributed again, so we can catch the traffic further out there. We're not funneling down. But the big question that everyone asks is, okay, well, where do I get rules? Where do I find rules? I heard AWS isn't a learning WAF, so where do I get rules? Well, a couple places. We've published a bunch of OWASP Top 10 and security automation rules. These are CloudFormation templates that you can go in, run them yourself. You kind of look, go through the CloudFormation template, deploy them. Put them out there. You put them in count mode. That would be my first coaching, is don't just deploy and block, deploy and count to make sure that it's catching the traffic that you want. And then once you feel comfortable that you've got these kind of tuned for your environment, off you go. And you can select one, some, or all of the various security automations. I'll get more into that in just a moment. So I don't know about the folks in this room. I'm sure you run circles around me. I'm a cookbook coder. If I can Google it and find an example, or if I have a template to go on, I can kind of, fuddle my way through and make it. So I'll create custom rules based on that. And I'll use those as a template and go, okay, let me steal this idea and tweak it and tune it and make it my own. So custom rules, this would be an example where you go, you know what, I've got a specific CMS, and they just discovered a vulnerability, but they issued a patch, and I want to take the patch, but it's going to break all these plugins that I've got because they're not forward compatible yet. What do I do? Okay, well, I'm going to go and write a custom rule. A typical one is a buffer overflow that they found in something. So you can actually write regular expression matches to go, okay, let me go in and on this post, on this page that matches this, limit this field to 1023, bytes, and that's it. And now we've created a custom rule to block. And you can do that. You can see how you can do that, of course, if your own vulnerability testing found things like that in your specific environment for a custom code that you've written in your DevOps, and you're like, geez, we might break this. We don't have time to test. Let's put a custom rule at the edge and just protect ourselves. And then there's some of you out there that are going, that sounds really complicated. Can't I just let somebody else do it? Yes, you can. We launched marketplace partners for rules too. So all of our friends here in the marketplace, you find your one or more of your trusted security partners, and you can subscribe to their various rule sets. So they have OWASP rules, bot protection rules, reputation listing, CVE for kind of zero-day attacks, various CMS packages, the Drupals and the WordPresses that they'll protect, virtual patches, and they can offer you that sort of protection. And this is not an either-or. You can actually mix and match marketplace rules, AWS predefined rules, and your own custom rules. You don't have to, it's not like we're excluding some. So you can pick the best out of each and deploy specific to your environment. And you can set multiple bundles of rules too, different access control lists, because we know not all of your environments facing the internet are homogeneous. So maybe you've got some Drupal over here, some WordPress over here, some custom stuff here, and an API here. You can set those rules up to protect in different ways. So here's a great example of those security automations. I really like this because it drives home the value of having a WAF that's API-driven and that's very responsive. And so in the top right here, what we've done, we've created a honeypot link, and it's hidden. And we've put it in our robots.txt file with a no-follow directive. So anybody that hits that link, I should say anything that hits that link, we know two things about it. One, it's a bot, it's not a human. And two, it's badly behaved because it ignored our no-follow directive. So what we do is we actually make an API gateway call, which triggers a Lambda function, and we've passed it the IP address of the offending bot, and we've updated the WAF via the API in near real time. These rules take place in about a minute or so, and now we're going to block that bot. So that's one example. There's a dozen or a half dozen, I should say, other security automation examples, and again, this is all in that CloudFormation template I referenced. So I have talked a ton. I'm going to bring my colleague Tarshia up here. She's going to talk about recovery at the edge, and then I'm going to bring home my promise to you to show you the biggest pricing cost savings hack at AWS. There you go.
Okay, hello. Can you hear me? Is my mic on? Can you hear me? Yes. Great. Okay, so at the beginning of the presentation, John talked about 2017 being a stormy year. Well, we're in the middle of 2018. There's volcanoes erupting, fires, floods, and all kinds of disasters happening. So how do we leverage our infrastructure to have recovery at the edge? He also talked about at the beginning, what's at the edge? And at the beginning of the conversation, he started here on the left-hand side with the end users, right? CloudFront, WAF, and Shield, and basically from the end user perspective. Now I want to talk about the origin perspective, from your customer data center and utilizing our regions for backup and leveraging our infrastructure. So from your data center or your office or your location, we're going to talk about how you can utilize Edge through the open internet, the AWS backbone, and using Direct Connect. and most importantly, how you can leverage our regions for backup and recovery. So scaling at the edge leads to high availability. So we want to keep your applications running 24/7. We want to make sure we're backing up your data and it's very secure and safe. And we want to get your applications up and running after a disaster. So there's some key components to disaster recovery. One is storage. So we have to store our data if we want to bring it back online. So we have block storage here, file storage, and object storage. I want to focus on two components. There's a lot of combinations in architecture for disaster recovery. Today, I'm just going to talk about using Amazon Elastic File System and Amazon S3 for storage. Okay, so Amazon Elastic File System is a great way to share your files. It's highly secure, it's very reliable, and you can share your files between EC2 instances in the cloud. For Amazon S3, we have object storage. Tens of trillions of objects are stored in S3 at any time. So it's very, very scalable, very reliable, and it's a great way to store your data and then be able to bring it back up online. So now that you've had it stored, and we talked about two of the AWS storage items, cloud data migration, moving that data is a key component of disaster recovery as well. So, and I'm going to talk about how we use our Snow family to migrate data and transport data. And I'm also going to talk about the storage gateway and direct connect as part of that. So when do we use Snow? Some of you may be familiar with our Snow family, Snowball, our Snowball devices, or Snowball Edge. Before I get started, they are also going through compliance with FedRAMP. Both the Snowball Edge and the Snowball device is with the JAB. The Snowball device itself for the intelligence community is already accredited for across the intelligence community. And Snowball Edge is currently under evaluation, and we should be hearing about that shortly. So when we're using the AWS Snow family, we use cloud migration, so just moving your data safely and securely at a low cost and very reliable way to the cloud. We also use our Snow family for data center decommissioning. So you've decided to move to the cloud, you're decommissioning your data centers. This is a great way to load your information up on Snowball devices and have them move safely and securely into the cloud. We also have content distribution. So you can share your files between your offices, several locations, your customers, and clients as well. And then lastly, we have disaster recovery. Bringing your files back online after they've been safely and securely stored is a key component of disaster recovery. So we use our Snowball devices, we use S3, we use Glacier to bring our files back online after a disaster. So we've talked about storage, we've talked about data migration. Now we're going to talk about Direct Connect, which is another part of Edge. Direct Connect is a physical connection to the AWS cloud. It's your private connectivity between AWS and your data center or location. It's usually hosted through a third party. I believe John mentioned that earlier, where it's in a colo provider. A lot of the telcos that you're familiar with will have space in their center, and you can just connect to AWS without actually having full-blown AWS account in architecture. It's a low-cost way of being connected to AWS. It's highly reliable and consistent. We have a global presence, so we talk about scaling. We talk about all of our locations. John mentioned we have 119 locations, edge locations globally. Within that, we have Direct Connect locations globally as well, in 83 locations, 58 cities, and 24 countries. With Direct Connect, you can also use our global network. And so you can talk to any of our AWS regions currently, except for China. The use cases for Direct Connect are having migration, hybrid architecture, using big data, archival, and backup and recovery. So how do we leverage Direct Connect to scale? So if you're looking at Direct Connect, we have a lot of resilient and diverse paths. So on the left-hand side there, you see our AZs and regions. So within all of our regions, we have 18 regions globally and counting. We have 55 AZs. So a region may have 2 to 3 AZs. And the reason they're structured that way is they'll be geographically separated so that we can have resiliency and backup and move data around in case one site goes down. And they're physically separated for those reasons. So if we're using our regions and our AZs, we have 2 transit pathways to get to a Direct Connect location. And again, I mentioned that it could be hosted by a third party. So you have here in this diagram, Direct Connect location 1 and Direct Connect location 2. And through that party, you actually access AWS at your office or your location. So again, we talk about scalability. So the map here depicts where we have a regional edge location, and you get a pretty big global view of our edge presence. Within that edge presence, Direct Connect has 83 locations. So we've talked about storage. We've talked about data migration. We've talked about connecting to the cloud using Direct Connect in the edge. Now we're going to talk about how do we do that. So I'm going to have 2 or 3 examples here. So the first one is using Amazon EFS, or Elastic File System. You can connect through Direct Connect and share your files. So you have your file servers and your file systems at your premise or location. And through Direct Connect, you can actually share those files and back them up in the cloud. So you're working over a dedicated network, it's secure, and it's a very easy way to back up your files. The next example is one from one of our customers, where we have active migration for our long-term object storage. So in this case here, you're seeing down at the left-hand side that Halliburton's data center has their servers. They have some long-term object storage, and they're going to use that Snowball Edge to bring their storage over, or their objects over to S3. So that's one way. And then you can also see that the file gateway at the bottom is where application storage servers are being brought through Direct Connect over to S3 in the cloud as well. So there's 2 ways that they're actually moving their data into the cloud and storing them. This is a very cost-effective way of storage and reducing your archives. They've saved 90%. And then also it's reduced their time to retrieve and load data from days or weeks to probably minutes, hours. So it's very highly efficient. The next example is Oregon State University. They use Snowball devices and Snowball Edge devices for research in the field. So as you can see here, they're off the coast in a ship, and they want to collect data offshore. And they were collecting 60 terabytes of data a week. With the Snowball Edge device, they're able to take snapshots and process some of the data offshore. But they're able to move large amounts of data at a low cost, so they don't need the infrastructure. They've saved $4 million. And then once they return back to their location, they can upload all of that data and analyze it a lot more quicker. So it's another way that we use our Snowball devices and Snowball Edge to have remote data collection. Another example is Southern Oregon University actually uses 2 of our regions or locations, one on the East Coast and one on the West Coast, to have disaster recovery. So they're using their bi-coastal data centers, and they're probably using, in this case, US East and US West, to store and back up and recover their files. And as you can see in the quote there, it was, we've saved them money, time, and cost in doing so. So with that, we also have a large ecosystem of storage partner solutions. And they all have gone through our AWS Storage Competency Program. So for primary storage, you can see we have NetApp, and others. For backup and recovery, Commvault, Veritas are some of the key names there. And then we also have partners for archive, business continuity, and disaster recovery. So I believe we promised you some cost savings. And so I'm going to have John come back and join me to talk about how low cost and effective using the edge may be in scaling on the edge. So the first one we're going to go over is Direct Connect. So with Direct Connect, as I described before, it's pay as you go. The pricing is per port hour for all of our locations all over the globe. The port charges are based on speed, and it's the same for all regions except for Japan. The data transfer in is zero. Costs you nothing to bring data in through all of our locations. And then there is data transfer out pricing, but it depends on the source and the region. And so, again, it's a very low cost effective way of connecting to the edge. And I'm going to go ahead and turn it over to John to
the pressure,
bring
the
it
big
home.
reveal. Thanks, Tarshia. So I promised you at the start that there is a great hack I was going to reveal to you to lower your data transfer out costs. And so that hack is CloudFront. The very first bullet there, there's no data transfer fees from any AWS origin to CloudFront. So whether you're using S3, EC2 ELBs, Elastic Beanstalk, ALB, whatever it is, there's no data transfer out fees to CloudFront. The CloudFront fee out is actually a ½ cent per gig lower than the native data transfer out fee for the corresponding region. So I challenged you at the very beginning. I said every single one of your HTTP, HTTPS, world-facing applications should go out through the edge. This is why. There are request fees that you pay on CloudFront that you don't pay natively a lot of times. We find that those are more than offset by fees in reduction in your back-end processing, whether it's gets or puts. And it's typically, unless you're running a very small web object size API or an ad network, I doubt there's anybody in public sector, maybe there is, those tend to be a few percent of the bill. So definitely would encourage you to look on the pricing calculator to figure that out. But that is the big reveal right there, is that the data transfer out is zero. We said, you know what, if we're coming back to the origin all the time, especially for static applications, we're not doing a good job caching, and so we want to do a good job. We have a positive incentive. We're not going to charge you twice when we should just be caching it at the edge. The second thing, there's no charge for regional edge caching. Some of our competitors call that midgress. We call that cache misses, and again, that's not good, so we're not going to charge you for that and give ourselves an incentive to have cache misses. We're going to have a great CDN. Again, we give you free certificates. There's no charge for CloudFront or Vanity SNI certificates. It's the same rate for HTTP and HTTPS traffic. The request fees are slightly different. And then the WAF pricing is 60 cents per million requests and some small fees for the rules and the ACLs. So very, very affordable and pay for what you use, consistent with the AWS pricing strategy. So the final thing, AWS Shield. Remember, Shield standards included in CloudFront, again, at no additional charge. You just get that. It's baked in protection. Shield Advanced, you pay one platform fee. It's a $3,000 a month platform fee. That covers all the accounts that are linked under that. So if you have like 6 sub-accounts or something, 6 into 3,000, $500 is what's going to show up as a prorated platform fee across all those various accounts if you turn it on there. And then you have a per gig fee, again, just for protected accounts. So some customers say, you know what, I've got a CloudFront in front of an S3 bucket. I don't need to protect that. I feel pretty good about my static objects in S3 and CloudFront coming under DDoS attack with standard. I'm just going to protect my CloudFront in front of my ALB because that's where I'm likely to get the trickier DDoS attacks, and so you pay those per gig fees just there. And again, you get WAF and Firewall Manager included with the Shield Advanced. So that was the big reveal. I hope you enjoyed it. We've got all the pricing is published online. We've got all the resources that we've linked here today. Oops, sorry, I'll slow down. People are taking pictures. I know I'm standing between you and happy hour here, so I don't want to get the hook off the stage. I think we got about a minute or two, so Nish, I think maybe we'll go around and just stay at the back here for questions. We'll handle Q&A there. Please do remember to fill out your survey, your session survey, and let us know how we did. And thanks so much for your time today and coming to Summit.